All right, today's topic is called conditional statements. Lots of writing today. So what I'm going to do is I'm kind of going to use my key that I made and just kind of move the paper as we go. But you guys are allowed to pause it and rewind or fast forward if you guys need to, all right? So what is a conditional statement? It's a statement that can be written in the if-then form. For example, if it's sunny outside, then it is warm outside, for example. The symbolic form, we're going to use P for the hypothesis part and then Q for the conclusion part. And this little right arrow in the middle is read as implies. So if you check out the little box on the right-hand side here, you can read as if P, then Q, or P implies Q. But for the most part, guys, we're going to use this guy right here. If P, then Q. All right. A couple of vocab words. The hypothesis is a phrase immediately following the word if. So the hypothesis is the stuff after the word if. The conclusion is the phrase immediately following the word then. So all the stuff that comes after the word then is considered your conclusion. First example says to identify the hypothesis and conclusion of the following conditional statements. If you live in Nashville, then you live in Tennessee. The hypothesis, the stuff after the word if. The conclusion is the stuff after the word then. So if you want to just kind of take some shorthand notes, underline once the hypothesis and double line the conclusion, that's fine with me. But you can also write down in words if you need to. Next one. If the sum of the measures of two angles is 90, then they are complementary. Hypothesis, stuff after the word then, conclusion, the words after the word then. Pretty simple. Number 3, if a quadrilateral is a square, then it has 4 right angles. Hypothesis, a quad is a square. Conclusion, it has 4 right angles. Okay, now next section, guys, it's going to give us a statement, and our job is to write it in the if-then form. If this, then that. All right. There's many ways you can write these. I'm just going to give you guys one example of how it can be written, but you can rearrange words. You can add a word or two if you need to, but the overall goal is to make this into an if-then statement. Statement, an obtuse angle has a measure greater than 90. The if-then form. If an angle is obtuse, then it has a measure greater than 90. Next one. All numbers divisible by 4 are also divisible by 2. If a number is divisible by 4, then it's also divisible by 2. Number 6. States on the East Coast border the Atlantic Ocean. Conditional statement. If a state is on the East Coast, then it borders the Atlantic Ocean. Number 7. Valentine's Day is in February. Conditional statement. If it is Valentine's Day, then it is in February. Number 8. Prime numbers only have 2 factors, 1 and itself. If a number is prime, then its only 2 factors are 1 and itself. Next page. All right. So this next section goes, these are what's called related conditionals. All right. So you have your conditional statement, which we talked about on the first page, and then you have 3 more related conditionals. You have the inverse, the converse, and the contrapositive. What is the inverse? This is formed by negating the hypothesis and conclusion. In other words, we're going to add the word basically not to the hypothesis and to the conclusion. Symbolic form, guys, this little squiggle right here, this little similar sign, this means not. So if not P, then not Q. And we'll talk some about these examples at the bottom in a second, all right? Converse, this is where we just basically flip. This is formed by exchanging the hypothesis and the conclusion. So we just kind of flip these guys around. All right. Symbolic form, if Q, then P. So we just flip the hypothesis and the conclusion. Contrapositive, you got to do both. You have to negate and you have to flip. This is formed by negating and exchanging the hypothesis and the conclusion. Symbolic form, if not Q, then not P. Flip and add the words not. Let's check out some examples. Says write the inverse, the converse, and the contrapositive of the following conditional statements. Determine the truth value. If it's false, give me a counterexample. Remember, that means to prove the conjecture false. Okay, first one. If it is Saturday, then there is no school. The inverse. Remember, this is where we add nots to it. If it is not Saturday, then there is school. Truth value? Well, it's false, right? It could also be Sunday. Next one, the converse. This is where we flip. If there is no school, then it is Saturday. Well, that's also false, right? If there's no school, it could also be Sunday. Contrapositive. Flip and add not. If there is school, then it is not Saturday. That is true. If there's school, it can't be Saturday or Sunday. Next one. Conditional statement. If the product of two numbers is odd, then both numbers must be odd. All right, so inverse, we have to add the words not. If the product of two numbers is even, then both numbers must be even. False. And here's your counterexample right here, guys. 4 times 7 is 28. So even though both numbers are not even, we still have an even answer there. Converse. This is where we flip. If two numbers are odd, then their product is odd. So for example, 1 times 3 is 3. 5 times 5 is 25. 3 times 7 is 21. So any two numbers that are multiplied together, you're always going to get an odd product. Contrapositive, flip it and add the word not. If two numbers are even, then their product is even. This is also true. If you take any two even numbers and multiply them together, you're going to get an even back. 2 times 2 is 4. 4 times 2 is 8. 8 times 8 is 16. 4 times 8 is 32. Okay, and so forth. Next example. Conditional statement. If the temp is 25 degrees, then it is below freezing. All right. Inverse, you got to flip it. If the temp is not 25, then it is not below freezing. Well, false, right? Remember, freezing is 32 degrees. So any number lower than 32 degrees is going to be freezing. So, hey, they said, hey, it could be 20, it could be 19, it could be 18, 17, 16, 15, whatever. Converse, flip it. If it is below freezing, then the temperature is 25 degrees. Well, false, right? The counterexample, it could be 20, it could be 21, it could be 22. It could be a lot if it's freezing, right? Contrapositive, flip it and add the word not. If it is not below freezing, then the temperature is not 25. That is a true statement. That is very, very, very true. Next page. All right. This page, these are called biconditional statements. So what is a biconditional statement? It is a conjunction of a conditional and its converse. Okay. In symbolic form, if P then Q, in conjunction with if Q, then P. Okay? This little arrow going both ways, guys, this is read as if and only if. If P, if and only if Q. All right? This little box is important. Put some stars around this bad boy. Biconditional statements are true when both the conditional and the converse are true. So kind of like we did in the previous page, we got to make sure these are both true for the biconditional to be true. Let's check out some examples. Given the biconditional statement below, write both the conditional and the converse, then determine the truth value of the biconditional. Explain why or why not. All right, here we go. Biconditional statement. Two angles are supplementary. Remember, guys, this word means they have to add up to 180 degrees. If two angles are supplementary, if and only if the sum of their measures is 180. Okay. The conditional. If two angles are supplementary, then the sum of their measures is 180. Yes, that is true. Supplementary angles have to add up to 180. Now for the converse, we flip it. If the sum of the measures of two angles is 180, then they are supplementary. That is also true. So my biconditional is true because both the conditional and the converse are true. So this biconditional statement is true. Number 2, I wear my snow boots if and only if it snows. Okay, so pull out the conditional, pull out the converse, and then we'll determine the truth values. Conditional. If I wear my snow boots, then it snows. False. You could wear your snow boots in the middle of summer if you wanted to. It really doesn't matter, right? So for that conditional, that is false. The converse, if it snows, then I wear my snow boots. Yes, I know you don't have to, but let's assume this was a true one. If it snows, put on your snow boots. Let's call it true. However, the biconditional is false because our conditional was false right here, right? Just because you wear your snow boots doesn't mean it will snow. Number 3. If x squared is 25, x squared equals 25 if and only if x equals 5. I see a problem with this one. Conditional. If x squared equals 25, then x equals 5. False. X could also be negative 5. If I take negative 5 and square it, I still get 25. The converse, if x equals 5, then x squared equals 5. If I take that 5 and I plug it in there, 5 squared is 25, right? So that guy is true. But however, the biconditional is going to be false because up here, guys, but if we plug in negative 5 here, we still get 25, okay? Our conditional is false. That means our biconditional is false. Number 4, I will get 10% off if and only if I spend at least 75 bucks. Okay, conditional. If I get 10% off, then I spent at least $75. True. Yep, exactly. That's what our biconditional told us, for sure. Converse. If I spent at least $75, then I will get 10% off. That is also true. So since both the conditional and the converse are true, your biconditional is true as well. Next page. All right, guys, on this last page, do not worry about the compound statements. Go ahead and cross that off. That's something more for honors geometry. This last little section, guys, is more some conditional practice. I'll fly through these, and then we will be done. All right, directions. Use statements below to write the conditional statements below. All right. Hypothesis, if it is St. Patrick's Day. Conclusion, it is March. Conditional statements, make sure you guys write in the symbolic form over here. if P, then Q. Conditional, if it is St. Patrick's Day, then it is March. Truth value, you bet. St. Patrick's Day is only in March. The inverse, remember, this is where we add the words not or negate. If not P, then not Q. If it is not St. Patrick's Day, then it is not March. Well, that's false, right? There's other days in March besides St. Patrick's Day, so that's why that one is false. Your converse, remember, this is where we flip. All right. If it is March, then it is St. Patrick's Day. Well, false, right? St. Patrick's Day is not the only day in March, so that's why that one is false. Contrapositive, remember, this is where we negate and we flip, right? If not Q, then not P. If it is not March, then it is not St. Patrick's Day. That is true, right? St. Patrick's Day is only in March. And your last one, your biconditional. P, if and only if Q. It is St. Patrick's Day if and only if it is March. That is false. Remember, because we talked about the conditional and the converse have to both be true, right? Well, in this case, our conditional was true, but our converse was false. So since both of these are not true, the biconditional has to be false as well. That's it for conditional statements. Thank you.